Hello, mathematicians. Today we are going to talk about ratios and proportions. A ratio is a fraction. We read it as 4 to 5, 4 over 5, 4/5. A proportion then is two ratios that are equal to each other. Okay? So two fractions that are equal to each other. For our first set of examples, we're going to talk about if these are proportional to each other. If they are proportional, they have to be equal, meaning they simplify down to be the same. So for these examples, we need to simplify both pieces. 4/5 is already simplified. How can we simplify 24 over 30? Divide them both by 6. You could divide them both by 2, you could divide them both by 4. Just keep simplifying or keep dividing until you can't. 24 divided by 6 is 4. 30 divided by 6 is 5. Are these two the same? Yes. So they are proportional. If you can simplify them down to be the same, they are proportional. Try the next one on your own. Decide if these are proportional. Let's see how you did. 2/5 is already simplified. How did you simplify 6 over 10? Divide by 2, and what did you get? 3 over 5. Were these the same? No. So are these proportional? No. Simplify, see if they are the same. Another way we can see if they are proportional is checking cross products. Cross products mean multiply the diagonals. So A times D has to equal the other diagonal, B times C. Okay, so this time we are going to check to see if they are proportional by checking cross products. So if I take a diagonal, 0.2 times 0.9, we want to know, does this equal, what's our other diagonal? 1.8 times 1. Okay. 0.2 times 0.9 is 0.18. And 1.8 times 1, 1.8. Are these proportional? No. They are close. They look almost like each other, but in fact they are not. Multiply your diagonals, see if they are the same. Try this next one on your own. Let's see how you did. What was the first diagonal that you multiplied? 0.4 times 1.4. What did you do next? 0.8 times 0.7. 0.4 times 1.4 is 0.56. And 0.8 times 0.7, 0.56. Are these equal? Yes. So are these two proportional? Yes. Check your cross products, see if they are the same. If they are, then they are proportional. If not, then they are not proportional. We are now going to use cross products to find missing pieces of our proportion. Right? So to solve these, I need to figure out what n is. To do that, I'm going to use cross products. So I'm going to multiply the first diagonal. So 16 times n. And I know that cross products must be equal in order for them to be proportional. I'm now going to take the next diagonal. 15 times 24. And we need to solve for n. So I have 16n equals 15 times 24 is 360. And how will you solve for n? divide by 16, divide by 16. N equals 22.5. Multiply your diagonals, solve to find n. Try this next one on your own. Let's see how you did. What did you multiply first? 3.2 times n. And what did you do next? 4 times 2.6. So I get 3.2n equals 2.6 times 4, 10.4. And how did you solve for n? Divide by 3.2, divide by 3.2. N equals 3.25. Multiply your diagonals, solve for your variable. We're now going to use proportions to solve word problems. We're going to pull out the key information and set up our proportion and then solve like we were. So Trent takes 4 hours to ride 30 miles on a bike. What are the two units that we are using? Hours and miles. So I'm going to set this up with my units, hours and miles. Fill in some things. I need my proportions. So I need two fractions equal to each other. So I have 4 spots that I need to fill in. 4 hours. Where will 4 go? In the hour spot on top. With the 4 is 30 miles. So 30 will go on bottom. These two must be in the same fraction as one another because they go together. The next piece of information I have is, at this rate, how far can he ride in 6 hours? Where will 6 go? On top in the hour spot. Do I know how far he rode then? No, so what will I put here? A variable. 4 hours goes with 30 miles. 6 hours, we're not sure. So how will we solve this? Multiply our diagonals. 4 times x equals 6 times 30. So 4x equals 180. Solve for x. X is 45 in my units, miles. Based off of that information, in 6 hours, Trent will bike 45 miles. Use your units, plug in the pieces you know, cross multiply, and solve. Try the next one on your own. Let's see how you did. What were the two units we were using? Centimeters and meters. So on this airplane, the scale is 5 centimeters. So out of my 4 pieces, 5 will go on top. What must go with the 5? 2 meters. Make sure you labeled so it's easy to find out where pieces go. If the wings on the model are 28.5 centimeters, so where does 28.5 go? On top. What are they on the actual airplane? 5 centimeters is the same as 2 meters in real life. The model is 28.5. We're not sure how far it is in real life. So what do you do to solve? Multiply your diagonals. 5 times x equals 2 times 28.5. 5x equals 2 times 28.5 is 57. And how do you solve for x? Divide by 5. Divide by 5. X equals 11.4 meters. The actual wings on the airplane are 11.4 meters long. Set up your proportion, label your units, plug in your pieces, cross multiply, and solve. Nice job today, mathematicians.